So here's the situation that this car rental company finds itself in. They have a fleet of 150 cars, and they've been renting them out for $48 per day. That's the charge per day. It's kind of expensive, but anyway. And at that price, they're able to rent all their cars out. They understand that if they raise their price, they're going to end up being able to rent out less cars, but they're thinking, I'm getting more money per car, so I might be able to end up with more money, which is my goal. So they think, okay, let's try changing the price a few times, $3 at a time. And when they did their research, they found that every $3 that they raised their price, they lost five customers. Five customers said, nah, I'm going to go next door. I'm not going to come to you for your cars because you're too expensive. I can go down the road and get a car for the same price, so I'm going to go down the road. All right, so you say that's fine. I'm in business to make money. I think I can do better by raising my price, even if I lose a few customers. So we're going to let X be the number of $3 price changes. If I change my price by $3, then X is 1, right? Every one, every time you change X by 1, you change your price by $3. That's what we're saying. So I'm going to put a price equation and a number of cars equation. Oh, I'm over here. I'm going to put a price equation down. And my price equation started off at $48. And every time I change X, my price changes by $3. That's why it's 48 plus 3X. On the other hand, the number of cars is going to start off at 150, but I know that every time my X changes by 1, which is $3, the number of cars goes down by 5. So it's going down minus 5X. So 48 plus 3X is how my price is changing. And 150 minus 5X is how my number of cars is changing. One is going up, the other one is coming down. It's just the nature of the market. You charge more, people start showing up less. No. What I care about is my revenue, right? And my revenue, which I'll short as REV, is equal to the product of those two things. How do I know how much money I make at the end of the day? Well, how many products did I sell and what did I sell them at? If I multiply those two things together, I'll get my revenue. I sold 6 items, $2 each. I should have $12. 6 times 2. So my revenue equation looks like this. 150 minus 5x, 48 plus 3x. That's my revenue. Now I'm trying to maximize that. This is a quadratic. How do I know it's a quadratic? What's the clue here that will tell me that this result that I'm looking at, oh, you know what I forgot to check? Oh, geez, that put the two together. So here we go. That's my revenue equation. That's how much money I'm making. And what I'm trying to say is that this is a quadratic function. How do I know that's a quadratic function? What is the clue that should lead you, when you look at that equation, to know that that's quadratic? How do you know what a quadratic equation is when you look at it? What's the clue that an equation is actually quadratic? Or it's going to lead to a parabola? Yes. You have an x squared term in there, right? Manahil was going to say the same thing, right, Manahil? Right? If I multiply these two things together, I'm going to end up with an x squared term, which tells me this is going to be a quadratic function. Now, if it's a quadratic function, it's probably going to have a vertex, and that's where my focus is, because I'm trying to maximize my revenue. So I'm looking for where that vertex is. That's my goal. Get to the vertex. Okay. Okay. Can anybody suggest how I might be able to find that vertex using this equation? Yes, Jane. That's a good point. I could FOIL it out. Then I could use completing the square, or I could use a quadratic formula to get it. Or, and that's the method we're going to use. I'm going to repeat what Manahil just said. if we knew the zeros of this function, right, set this equal to 0, set your revenue. You don't want 0 revenue. You don't want that. Okay? But if you knew where those zeros were, then you could find the axis of symmetry, which is the center between the two zeros, because you know that your vertex is on that axis of symmetry. And that's what we're going to do, because that's the easiest way to do it. Right? Yes, you could use what Che just said. Absolutely. Foil it out, complete the square, use a quadratic function. But what we're going to do is we're going to follow the Manor-Hill method here. We're going to find the zeros. So I'm going to set this equal to 0. Right? Not that we want the revenue to be 0. Oh, keep forgetting I have to do it over here. Not that we want it to be 0, but we're going to find the zeros. So how do we do that exactly? I set it equal to 0, but what do I do now? Come on, folks. I don't need the same people all the time. I can't have them carrying the load for the whole class. Gary. Zero product law. Thank you very much. I couldn't have said it better myself. Zero product law says if I multiply two things and get 0, one of them has to be equal to 0, or both. So we're going to say that either 150 minus 5x is 0, or 48 plus 3x equals 0. It cannot be that when you multiply two things and get 0, one of them isn't 0. Either this is 0, or they're both 0. So we're going to consider both possibilities. We're going to go ahead and solve those two equations right now to see what the zeros are. Okay. So let me just shift that minus 5 on us. I'm going to say 150 is equal to 5x. Does that make sense? And I shifted it over like that. I'm taking the minus 5x and putting it on the other side as a plus. So that hopefully makes sense. Therefore, x, dividing through by x on both sides. Not by x, by 5, sorry. Dividing through by 5 on both sides. Means that x is equal to 30 by my math, my mental math. Remember, I'm the one who's always touting, trying to do things in your head, which is not always a good idea because sometimes you make mistakes, and I have in the past too. Anyway, I'm going to say that's 30. I'm going to do the same thing here. I'm going to take that 48, put it on the other side. So 3x is equal to minus 48. So therefore, x, divide both sides by 3. X is equal to, I'm going to say minus 16. You double check that. Make sure I'm right. You guys have the calculators. I don't. Okay? Thanks for doing that. I appreciate that. All right. So I'm getting minus 16. And tell me again why we did this. What's the next step in the process? What do we do with these two numbers for us to know where the vertex is? There was a point to us knowing where the zeros were. Yes? Pardon me? Find the axis of symmetry. And how do I take the zeros and find the axis of symmetry? What do I do with the zeros to find the axis of symmetry? Is what I'm asking. You're on the right track. Does anybody remember? What we have the zeros now, but what do we do with them? That's the question. Right? What exactly are we going to do with these zeros? Yes. Add them together and divide by 2. Thank you very much, Nakib. So the axis of symmetry, AOS, would be equal to 30 plus minus 16, or 30 minus 16, divided by 2. 30 plus minus 16 is 14, divided by 2, which is 7. Agreed? Remember, I'm doing this mentally now, right? So I'm sure you'd let me know if I made a mistake if I did this mentally. Am I right? Am I good so far? Abdullah? Yes? Okay. Abdullah says I'm good, so I'm going to assume he's right, and I'm right. So if the AOS is 7, let's go back and look at the question, because we haven't answered the question yet. The question is, what's the maximum revenue the company can earn? So what am I going to do with that 7? What exactly? Yes, Yash. Into the revenue equation. We're trying to maximize revenue. We're hearing that the maximum occurs on the axis symmetry when x is equal to 7. Let's put 7 into the revenue equation. So let's do that. So my revenue is equal to the 150 minus 5 times 7 in one bracket, and 48 plus 3 times 7 in the other. Am I going too fast? Please, please. I know there are some people who are good at telling me, Mr. Kamok, you got to kind of slow things down here. And I applaud them for that. So let me know if I'm going too fast, please. Okay, let's see if I can do this now. So the revenue is equal to 150 minus 35, I'm getting for one bracket, and 48 plus 21 in the other. So this is 115 times 69. 69. Okay, that I can't do. Sorry. I think I'm good, but not that good. Thank you, Shreyas. Go ahead. 7,935. Thank you. Now, are they better off than they were before? Now, remind me now, what was their situation when they started off? How many cars were they renting? And how much were they charging per day for those cars? Right? Because I need to know, am I really doing the right thing here? I'm the one running the show now. I'm the boss of this business. I'm the manager. I'm the owner. Right? Did I do a good thing by changing up my price? What was I making before? Right? Go back and look at it. Yes, Africa. Okay. 30 plus negative 16 because you add them together. I could have, yeah. I just want to make sure that in future people will recognize that I really should be adding them. So that's why, because if I put minus, people think, oh, you minus them. No, you add them. But just that one is a negative. Okay. Thanks for the question. That's actually a very good question. So how was I doing before is the question. Can you tell me, please, Amir? How was I doing before? Right? How much money was I making before? That's what I'm making if I make the changes. All right, I try to maximize. But what was I making before I made these changes? Look at how many cars I was renting. Look at what I was renting it for. And tell me how much I was making before. That's the question I'm asking. Because I need to know whether I'm better off. Should I just stuck with what I was doing or do I really need to change the price? All right, let me go back and show the question again. All right, I want this to be a practical exercise. Right? Look at my current situation. How much money was I making before? Yes, Atifa. 7,000. And how did you get that? There you go. Right? I was renting 150 cars at $48 per day. So I just multiply those two things together. And what I'm hearing from Atifa is that I was making 7,200 and sorry, 7,200 flat. Compare that 7,200 to 7,935. Now you're in business. Which one of those do you prefer? Okay. Yes. Yeah. Okay. Let's just be honest about it. Right? Okay, so 5 people decided not to come to you anymore. Okay. I mean, I don't want to seem glib about it, but what do you care about? You care about the bottom line, right? That you're making more money. That's your goal. You're going to keep those people happy that stayed with you, but you're making more money. So you're happy as well. Okay. Now, that answers the question about the maximum revenue. So let me put a statement for that. So the answer for part A, maximum revenue the company can make with these changes. Max revenue is 7,935. Please don't forget to put these statements in. That's where I'm trying to make sure that I set a good example by putting a statement in at the end. So I've answered part A of the question. Part B of the question asks a little different thing, but still is important for us to answer, which is what is the rental charge and how many cars should be rented to maximize the revenue. So we know how much money they're going to make, but how many cars should they expect to rent? And what price is this scenario suggesting? X is 7. That's what X is. That's what X is. X represents 7 at the maximum. Now, let me remind you what X represents, right? X is the number of $3 price changes. So if X is 7, what price are they now renting their cars for? That's the question. Okay, that's the question that needs to be answered. I see some of the same hands every time. Okay, let me hear from Suchir. Suchir, go. How do you know that? Yep. In fact, we kind of worked that out down here when we did the calculation. Where was it? Yeah, the 69 is right there. When we took the 48 plus the 21, that's the answer right there. So the price for max revenue is $69. So you've actually raised it 7 times. 7 threes are 21. 21 on top of the 48 takes you up to $69. So it's a pretty expensive car now. I mean, to be honest with you, I don't rent cars for that amount of money. When I do rent cars, that's really expensive, unless it's some really fancy car. But that's the price you're now charging for your cars. You lost some customers. How many customers do you still have at that price? That's the question. Okay, Che, what do you have? Which is what we had up here already. You kind of gave it away by doing it this way. That 150, every time you raise it by $3, you lost 5 people. So take that 5 and multiply it by 7, which gives you 35. You lost 35 customers. So now you are down to, you will be renting, you can rent 115 cars. So you actually have some extra cars on hand that can be rented because you raise your price. And you knew that. You knew that you're going to lose some people. You did the analysis, you did the market research, but your bottom line, your pocket is now fatter because you changed your price. Okay? Let's move along. Any questions on that? Are we good so far? All right. Athusian says he's good, so I'm going to move on. Let's tackle this one. I'm trying to do a lot of application type questions, a lot of questions that could be based on everyday experience, right? Sometimes I know math can be a little bit abstract, like, do we ever get to use this in the real world? Well, let's talk about a situation where you could. Open top box is formed by a piece of metal measuring 100 by 45, and I've put the 100 by 45 in the diagram. The sides of the box are formed by cutting 4 identical squares from the corners. If the base of the box has an area of 1596, what's the height of the box? Okay. So let's think about that now. Yes. Okay. What's that? Make it bigger? Yep, we can do that. We can do that. We can do that. That better? Okay. So how we form this box is we take the big piece of paper, the outline of the big piece of paper, and we cut these little squares in the sides. So we'll call the size of the part that we cut out, we'll call that X. These are squares. So everywhere we see an X is the same height. So if you can imagine, I don't have a box here. Actually, I do have a box here. Just imagine that the box, you flatten out the box, and now you're folding it back up to create the box. So you're cutting out these little corners here and creating the box. So what height should you make? Now remember now, this is going to be height right here. That X is going to be the height because you're folding up the sides to create the box. Hopefully that visual makes sense to you. Each of these is being folded up to create the box. So the bottom of the box, just so we know, we put a dotted line in to represent the bottom of the box. Okay, where's my thing where I get, oh, I don't know what's, Oh, because I have this thing in. Maybe I should take that off. Yeah. All right. Let me change something up here. Maybe I can do it over here. All right. Maybe I can do it over here. Okay. So I'm going to put a dotted line in this thing here. That's thick. I didn't mean it to be that thick. This represents the bottom of the box. Okay, that pink line represents the bottom of the box, and we're folding up the sides to create the box. What we know is that the volume of the base has an area of 1596. We know that the whole thing here is 100 by 45. So, does anybody have any notion as to how we can set anything up to figure out what the height of the box needs to be? The base has an area of 1596. So this area here is 1596, 1,596 centimeters squared. So what do you say, folks? What's the length of this side on top here? Right? And what's the length of this side over here? Because we know that the area in the middle here is 1596. But can we come up with an equation to represent that area? Do we know what the length of this? We know the length of the whole thing is 100, but we cut off a piece on this side, we cut off a piece on that side to create the box. So any notion of what the pink line of the length should be, or the length of the pink line at the bottom of this thing should be? Yes? Listen to you. Well done. If this whole thing is 100, and I'm taking off an x to create this and another x on this side to create that, why don't I call this thing here 100 minus 2x? Right? From here to here is 100 minus, because I'm lopping off an x on both sides. And the same thing would apply to this side. So somebody else, apart from Manahill, tell me what I should call the length of this side over here. Yes? 45 minus 2x, absolutely. I'll put that over here. Right? And it extends, this is for both sides. So what we need to do now is come up with something to link that information with the area of the base of the box. The base of the box, we are told, is 1596. Put that all together now, right? Link those two pieces of information together. That pink box right there, that outline that I have in pink, that is the base of the box. Okay? Che thinks he has something for us. Go ahead, Che. But of course, isn't that how we find area? Multiplying length by width? Isn't that how area gets calculated? So why don't we do that? Why does that make sense? Let's do that. Let's do exactly that. So I'm going to go ahead and I'm going to take the 100 minus 2x multiplied by the 45 minus 2x and set that equal to what we know it is, which is 1596. Have I done anything that anybody isn't comfortable with so far? All right, you let me know. Right? Can I move ahead here? All right. Jasmita, how about you? Are we good here so far? All right, let's continue. Well, I don't know what to do now. We got the beautiful equation from Che, but we don't still know what x is. Okay? What are we supposed to do now with this? Is the question I like to ask. I need to know what x is, and I still don't know what x is. Yes, Yash? I think that's a great idea. I think that's a fantastic idea. We're going to foil this. No, that's a lot of work because it's some really big numbers, but nobody said that it was going to be easy. So let's go ahead and do exactly that. 100 times 45, I believe, would be 4,500. 100 times minus 2x would be minus 200x. Minus 2x times minus 45 would be minus 90x. And minus 2x times minus 2x would be positive 4x squared is equal to 1596. Okay. Yes. Negative 45. Did I do something wrong? It's negative. So remember, FOIL is this. Let me put a different color on that. Is this times this, which gives us the 4,500. Then we're going to take the 100 times the minus 2x as well, which is the minus 200x, right? But then we also take the minus 2x times the 45. Oh, I mean negative 90. Yeah. If I said negative 45, then that's just totally rubbish. Okay, sorry. Negative 90x. Sorry about that. Okay, so we filed it, like Shreya said, but I still don't know the answer. Yes, we should probably do that as well. Let's group it. Okay, so let's go ahead and do that. So Naomi says we should go 4,500. I should go back to black, but anyway, minus 290x plus 4x squared is equal to 1596. Okay, that's a good step. I like that, and I like that people are at least participating, but not everybody is. So, at some point I'm going to start pulling out my names and start calling out some people. Okay, let's talk to AJ now. AJ, what do you want to tell us? Say it again. The 4,000 over to the right side, you mean? Um, not sure about that one. I have an idea that's very close to what you said, but it's almost the opposite of that. But it's on the right. It's what? Tell me, give me another strategy. Because we want to make it equal to zero. You're trying to solve a quadratic. If it's equal to zero, then you can start talking about using the quadratic formula, factoring it, all kinds of things. But it has to be equal to zero first. So instead of moving the 4,500 over, let's move the 1596 over. Set it equal to zero. Okay, Jay? So we'll do that. Let me go back to black. So the 4x squared, I'm going to put the x squared term first, minus 290x, and then plus the 4,500 minus 1596 equals 0. Can we all agree on the math that's involved there? Rosie, how about you? Is that good so far? Make sense? Yes or no? Hell, talk to me. Yeah? Okay, good. All right. So what do you think, following on something that Naomi suggested earlier on, what do you think I'm going to do now? Yes, Vanya. Yeah, meaning just put the like terms together, right? Okay, so we'll do that. So 4x squared minus 290x. Okay, I need help. Help me out, please. Help, help, help. Yes, yes, Yash. 2904, thanks. 2904 equals 0. All right. I'm assuming that there wasn't any mistake. All right, I've heard about it. So there we go. No answer yet. Okay. We're doing all of this stuff and we still don't know what the height of the box is. We still know what x is the height of the box, right? That's what the x is. But I still don't know what that is. So what am I supposed to do now? I'm stuck. You want to help us out here? Atuzan? 4x squared minus 290x plus 2904 is equal to 0. We got 2904 from Shreyas just now. But I'm trying to solve for x. What do I do? Give me some ideas. We hit a brick wall here, and we need you to bail us out. Divide what by two? What are we dividing by two here? What's that? All of it meaning every term? Anybody have another idea that's very close to that one, but not quite that one? Akifa? Factor of what? The four. That's what he said, right? Of course. Isn't that the common factor there? Isn't four a factor of all of these numbers? I believe it is. Yes. It does? Oh, so maybe your idea was better then. I don't know why I thought that it would have been divisible by four. 100 is divisible. You sure about that, dividing by four? Oh, you're probably right. You're probably right. Okay, so we'll take your idea then. We divide everything by two then. We'll factor out two. Let's put it that way. So 2x squared minus 145x plus, 1802. No, that's not right. That's not right at all. Divide 2904. Yes, sir. 1415, 52, 1452 equals 0. Okay, thanks. Oh, the 290 is the one that's going to give you the decimal, right? Yeah, yeah, you're right. You're right about that. Okay. Yeah, I was just thinking about the 2904. All right. Good point. That still doesn't give me an answer. What would you suggest we do next before we even think about anything else? What have I said to you before when you have something looking like that? Anybody remember? I have 2 times something equals 0. And I'm trying to solve for the x. Wouldn't I? Looks like you want to tell us something, Jahid. No? Or are you just scratching your face? I can't tell which one. Eh? Say it again. Zero product law? Not so much. I'm just going to divide the two sides by 2, right? Because that is going to eliminate the 2 that's in front here. And if I divide that side by 2, it's just going to still be 0. So I'm dividing, basically, everything by 2. I'm dividing this side by 2, dividing that side by 2. This side just becomes 2x squared minus 145x plus 1452 equals 0. That's all it is so far. Okay. So what do you want to do now, folks? What do you think is the most efficient strategy for us to finally crack the case here, right? We still don't know what x is, and that is our goal. Suchir, the magic x could probably help us out. Yes. Quadratic formula might even be faster because it might take, with numbers as big as this, it might take us a while to figure out what that combination is that would work. I'm going to suggest that maybe just going to the quadratic formula for something as big as this probably makes the most sense. But you're not wrong. In fact, I'm going to say you're right. We could go with magic x on this and try to factor it. But we're going to be, is it lazy? No, I don't think it's lazy. We're just going to use the quadratic formula, okay? So let's go for the quadratic formula. And it may not be factorable, by the way, just so you know. It may be something that has an irrational 0, which means that it's going to give you a square root of something like maybe 5, which means you couldn't have factored it in the first place. So I'm going to go ahead and use quadratic formula. Let me put that quadratic formula over here on the side to remind you what that is. Minus b plus minus square root of b squared minus 4ac all over 2a. Don't memorize it, folks. I've been doing this for a while, so that's how I know it. But I'll give that to you on a test. You don't have to memorize it. No point in doing that. So we know what our A is. We know what our B is. We know what our C is. Let's get this show on the road. Abel, give me A, B, and C, please. All right, so you're definitely going to need your calculator. Some of you have those really nice calculators, like the virtual one I have on the screen here, and that Wanya has, that you could just throw those numbers into the calculation, the quadratic solver, and it pops out the answer. But you're not going to have that tomorrow. So you might as well get used to using quadratic formula, which is what we're going to do right now. So x equals the x that we're trying to find. Minus b would be 145 plus minus. Remember, b was minus 145, so minus minus gives you a plus. The square root of minus 145 squared minus 4 times 2 times c, which is 1452, all over 2 times 2. Okay? Let's see how much of this I can do in my head. Not much. I'm going to be honest, I can't do much of this in my head. I know my limitations, folks. Plus minus the square root of over 4. Okay, that much I can do. Can you help me out with what this is? Minus 140. Well, just going to be positive. So 145 squared minus all of that. Can you help me out with that, please? Yes. 21,025. Thank you. Like that? Okay, over 4. Is that a perfect square? I don't know. Is it? Can you square root that and get a regular number? You do? What number are you getting? 97? Okay, thanks. So that's equal to two numbers, two answers. 145 plus 97 over 4 and 145 minus 97 over 4. Okay? I'm assuming you've tried this for yourself, so you're going to agree with what I just heard as a square root of 21025. Right? You all have your calculators. I can't do that in my head. It should be what? You should get 9409. Oh, I see. Oh, and then that gives you the 97? Oh, okay. Folks, let me not mislead you. Thank you very much. I appreciate that. Let me make a quick change here. Sorry, give me the number on the square root sign again. Thank you. And then that gives you the square root of that. So, okay, so fine. Okay. So minus 100 from that should give you 48 over 4 minus 100 from that. So no, this should be adding it. Sorry. What am I doing? What am I doing? This one is 48 over 4. This one is not. This one is 242. Am I right? Okay. Thank you. So this would be, well, okay, this one is 12. We do the easy one first. That one is 12. And this one is 60 something. What is this? 242 over 4 is what? Yes. 60.5, thank you. Now, let's go back and see whether these answers make sense. When you're doing a question like this, you always have to ask, is my answer reasonable? I'm getting two values of x. One value of x is 12 centimeters. The other value of x is 60.5. Should I put that the height of the box could either be 12 or 60.5? What do you think? Let's throw that out to you. Are both answers fine? Can I accept both answers? Or is one of the answers going to cause a problem? Because one of them is causing a problem. Mathematically, it's good, But because we're dealing with a practical situation, turns out that one of those answers can't work. Okay? Why anybody want to tell us? What's that? Round it down, maybe 60. Okay. Unfortunately, it still isn't good. What's wrong with 60? 60.5? Mathematically, that answer is good, but in practical terms, it is garbage. Okay? Why is it a garbage answer? Can you make the height 60.5? Let's go back and look at this a second. Can you make the height of this thing 60.5? Is that even possible? No. Why? Yes. What's that? Well, one side is only 45. That's part of the problem, right? So how are you going to get a 60 height? Remember, you're taking off x on both sides. So you're going to take away 60 from 45? How is that going to make sense? Right? And you're not even taking it once, you're taking it away twice. You're taking away 120 because you're taking away 45 minus 2x. Here's why that answer works mathematically, but doesn't work in practical terms. If you take 45 minus 120 and take away 100 minus 120, right, 60 on both sides, you get two negative numbers, which when you multiply and give you a positive number for here. But does that make sense in the real world? Can you have a negative length and a negative width? No. So sometimes the math might say one thing, but when you compare that to reality, you have to say, but we have to rule one of the answers out, right? So one of the answers of 12 makes sense, right? So I should therefore say that one of the answers is inadmissible. Where's my stylus? So x cannot be, in this situation, it cannot be. Mathematically, it will work, but in this situation, it cannot. So x cannot be equal to, let me write that out in words. Our height cannot be 60.5. Let me say it that way. I'm going to show you another reason why that answer is inadmissible. Can't be 60.5. So the applicable answer, the one that actually is applicable to this question, is a height of 12 centimeters. Cool. No, let me show you a reason why that is. You know, we talked about domain and range and all that good stuff. So much time we have before we get to the break. What is the domain of this question? What x values can you possibly have? Well, here's the thing. This distance here, 100 minus 2x, has to be greater than 0, has to be positive. This 45 minus 2x also has to be positive. So when you get an answer which suggests a length and a width which is negative, mathematically that might be fine because two negatives multiplied give you a positive, but in reality it's not going to work. Not for this situation. The domain of this situation is that this has to be greater than 0 and that has to be greater than 0. The length that we get must be greater than 0 and so must the width be greater than 0. So that's why you have to check your answer against the reality that you're dealing with. So there's my answer. Let's see if we can at least start. 11:04. Let's see if we can at least start. I think it's one more question I have for you for the problem set. Let's see. That's this one. Yeah. And there's some similarities, but it's not the same. And in fact, this one says round your answer to the nearest tenth of a centimeter. Maybe we can squeeze it in before the break, and then you have the whole second period to do review. Okay? In fact, you know what we'll do? We'll just finish this up, and I'll give you a break. All right? We'll just finish up this question. So remember, anything that you've done Starting yesterday when I said we're looking at problem set questions, including what we've done today, that's potentially on the assignment part, the thinking and inquiry part of the test. Okay, let's read this one and start to get through it here. A photograph measures 20 by 35 centimeters. So the photograph is the inside rectangle. And it's surrounded by a mat. A mat of a photograph is just the sort of border around the photograph. That's what a mat is. So it's surrounded by a mat before framing. The width of the mat will be equal on all four sides. So the width. I'm not saying that the length of the mat and the width of the mat are the same. The width of the mat, right? All of these, we can call them x, right? We can just call them x right now. Let me just label all of these as x. So this distance from here to here is x. This distance from here to here is x. There's an x here. There's an x here. What I mean by there's an x is that the distance from the edge to the edge is x. Okay, so hopefully everybody is following me as to what that x represents. The width of the mat, right? How wide is this border around the thing? It's equal on all four sides. So it's not like the thickness is bigger here than it is here. It's a uniform border around all four sides. The area of the mat will be twice the area of the photograph. Determine the width of the mat. Only the nearest tenth of a centimeter. Here's what rounding to the nearest tenth of a centimeter would suggest. That this time, I'm probably not going to get a nice, neat number like 12, which we got the last time. This time it's probably going to be some decimal that comes from an irrational number. You probably have to take the square root of like 15 or some number that doesn't have a rational result, right? But let's see if we can figure this out now. The area of the mat will be twice the area of the photograph. Can we start off? And what we know, by the way, is that x represents the width of the mat. That's what we know. That's what we're calling. That's our let statement. I need to know. Here's the first question I'm going to ask. Do we know the area of the mat? It says the area of the mat is twice the area of the photograph. Do we know the area of the mat? Think about that, because I'm not going to answer that question. One of you is going to have to answer that question. Let me go in the front here, right? Amira, go ahead. Not Amira, sorry. Aria, go ahead. Good. Thank you very much. So go ahead and tell me now, please, what is the area of the photograph? Yes. Right? So how much is that? So you're going to multiply them, right? Go ahead and tell me what that is. The area of the photograph is equal to area of photo is equal to, you said 20 by 35, right? That sounds like 700 to me. Yeah, I'm not the guy with the calculator. You are. So you tell me if I'm wrong. 700 centimeters squared. Okay, so that's the area of the photograph. Arya said something about the area of the mat. Look at what the question says. All right, and you tell me what Arya just said. Go ahead. So therefore, we should do what to find the area of the mat? That's what Arya said. Double it. So the area of the mat is equal to 700 times 2. Again, I'm not going to reach for a calculator. That's 1,400 centimeters squared. Does that take us any further? Our goal is to find the width of this mat that's going to make that magic happen. So what do I do next? Manahil, what do you want to tell us? 1400. So you're saying that the 1400 here would be equal to what? Mhm, mhm. You're on the right track there. You're on the absolute right track. Here is the first thing I would do, and I think this is following on what you just said. What is the area of the two things together? All of this, mathematically speaking, or algebraically speaking, or mathematically speaking. What's the area of everything here, right? So that's the photograph in the center and the stuff on the outside. What's that area? How much is that area? Yes. Pardon me? No, because 1,400 is just a mat alone. That's just this little strip on the outside. So that's the 1,400. But what I'm asking for, though, maybe I didn't state the question properly, is what is the area of everything? That's the question I'm really asking. Shamin, not Shamin, sorry. Who had their hand up? I think. Yes. So, Anjali, what do you think? So, let's add the two together. Okay? Let's put those two together because the picture is the 700, the mat is 1400. So let's add those two together because that represents the whole thing. And we're going to take Manahil's suggestion after that. So the total area that's taking both the mat, that is mat plus picture. In fact, I'm going to put this over here. Let me move this whole thing here. So total area, and by total area, I'm talking about mat plus picture or photograph is equal to the 2100 plus the 40. Sorry, I'm putting the answer before the question. Is equal to the 1400 plus the 700, which is the 2100 cm squared. Good. What are we supposed to do with that, though? Okay. So now I know that the total area. Remember, my goal is to find the width of the mat. Okay. But now we have that the whole thing is 2100. You were saying something very interesting, though. I don't know if anybody heard what Manny Hill said earlier on, but that kind of is the key to our next step, right? Give me, okay, let me say it. Like I want to rephrase what you said. Give me a mathemat or algebraic way of writing what this total area is, which includes that x, which includes the x. Let's not play with the phone yet. I'll give you a chance to do that in a minute. All right? Gary, what do you want to say? Good, good. Remember, this is a 20 by 35 picture in the middle here. This is our 20. This is our 35. Right? So if we look for the line on the top edge of this would be 20 plus 2x, not minus 2x. This line here would be the 35 plus an x plus another x. It will be 35 plus 2x on the side over here. Stop me, folks, if I'm going too fast. I always say that. Does the plus 2x make sense? The last question was on minus 2x because I'll go back a second here. Because we had a 45 by 100 on the outside and we were looking for the part on the inside. So we took off the x on that side. This time we have the inside dimensions But we want to get the outside dimension. So we're adding on that x. That's what Manuel was telling us to do. Okay, put it all together for us now. Piece that whole thing together like a puzzle for us now. Right? Give me that next statement. Go ahead, Sachir. Of course. Of course we can do that. Absolutely we could do that. So we're going to take the length and width, the 35 plus 2x, and multiply that by the 20 plus 2x, and set that equal to 2100. That's what we need to do. That's exactly what we need to do. Now, I think if you remember how we did the question before this, you know exactly the steps to complete this. All right. Triash, what do you want to tell us? Okay, so let's do that. So that would be 700 plus, I'm going to say 70x plus 40x plus 4x squared is equal to 2100. I'm going to stop now. I'm going to stop the recording. I'll restart the recording when I get you to give me some answers. Follow the steps that we did on the previous question to this. In fact, let me ask that question before I stop the recording. What is the next step that we have to take after we get that line? What's the very next step? Go ahead, Athusa. To set it equal to 0, absolutely. Right? So we'll do that first. I'm going to put the 4x squared first. What about the 70x and the 40x? Can I combine those two? Yes. Yeah, like terms, plus 110x. Then we have the plus 700 minus the 2100 equals 0. Okay, so I'm going to stop.